There's a moment in almost every workshop when you pull a cluster out of a car, flip it over on the bench, and realize this isn't the usual version you were expecting. The connectors look familiar, the housing feels the same, but the internal layout tells a different story. That's exactly what happens with certain Volkswagen Golf 7 models running the Johnson Controls instrument cluster. At first glance, you might assume it's just another standard MQB setup. It's not, and if you treat it like one, you can get yourself into trouble fast. Welcome back to Baabji Motors. I'm Hussein, and today we're digging into the Volkswagen Golf 7 JCI cluster that uses the D70F3426 processor paired with 95-128 EEPROM. This discussion is strictly for educational and informational purposes, aimed at professional technicians and learners who work in legitimate automotive repair environments. Always follow local laws, manufacturer guidelines, and proper documentation procedures when dealing with instrument clusters and mileage data. Now here's a question I want you to think about as we go through this. When you're choosing between CG100X and Yanhua ACDP for this specific cluster, is the extra wiring and component handling worth it, or does simplicity win every time? Stay with me, because by the end I'll give you a clear perspective on which route makes more sense depending on your workshop reality. Let's start by understanding what makes this cluster different. The Johnson Controls unit in certain Golf 7 vehicles does not behave like a regular MQB cluster with a straightforward EEPROM-only structure. Instead, it combines a Renesas D70F3426 microcontroller with an external 95-128 EEPROM chip. That means the mileage data is not isolated in a single tiny memory area. It's distributed and secured across flash and EEPROM sections. If you only touch one side, the system will reject the change or throw inconsistencies. Take a real-world example. Imagine a cluster with part number 5GG92860. Let's say the original mileage stored in the vehicle is around 163,979 kilometers. When correcting or adapting data for legitimate repair scenarios, you must read both the processor flash and the EEPROM content before doing anything else. Backup is not optional. It's your insurance policy. Using CG100X, the workflow is methodical and hardware-intensive. Inside the software, you select the MQB D70F3426 family and choose the remove capacitor method for D70F3426+95128 using interface B. The wiring diagram is critical here. You must remove specific capacitors as indicated in the official diagram to isolate communication lines properly. This is not guesswork. If you skip that, you risk unstable reads or corrupted data. A D1 adapter is required for proper communication. Once everything is wired according to the diagram, you enter the operation menu and select the D70F3426 flash option. The first step is reading and saving the full CPU flash data. This file is large, roughly 2 megabytes in size. That size alone tells you it's not just a simple odometer value sitting in plain text. It's integrated into a broader memory structure. After securing the flash backup, the next step involves the EEPROM. Here is where precision matters. You must physically remove the 95-128 chip from the board. Do not rely on a solderless clip adapter. In real workshop conditions, clip connections on these clusters are unstable and can introduce read errors or partial dumps. The safest method is desoldering the chip cleanly, placing it into the CG100X EEPROM adapter, and then reading it directly. The EEPROM file is much smaller, about 16 kilobytes, but it is equally important. Interestingly, while you remove the EEPROM chip, you don't have to remove the temporary solder wires connected for CPU reading. That saves a bit of time. Once both original files are saved securely, you move to the odometer function in the CG100X software. At this point, the tool requires an active network connection. The system verifies the original mileage by analyzing both flash and EEPROM data together. After confirmation, you input the desired mileage value for the repair scenario. The software then generates 2 modified files automatically, one for flash and one for EEPROM. This dual file generation is crucial because consistency between processor flash and EEPROM is what keeps the cluster stable. Rewriting begins with the EEPROM. You load the newly generated EEPROM file, paying close attention to file names to avoid mixing originals with modified versions, and write it back to the 95-128 chip. After soldering it back or preparing it for reinstallation, you return to the flash menu, upload the new flash file, and rewrite the D70F3426 processor. Only after both sections are correctly written do you remove wiring, reinstall the EEPROM onto the cluster board, and refit the cluster into the vehicle for verification. If everything was done properly, The new mileage will display consistently without fault codes. Now let's contrast that with Yanhua ACDP, specifically using Module 34. This is where workflow simplicity becomes very obvious. Instead of removing capacitors and running multiple jumper wires, ACDP provides a dedicated interface board designed for this exact cluster type. In the software, you navigate to the MQB48 JCI D70F3426+95128 section, then select the D70F3426+95128 option, depending on cluster labeling. In practice, many of these processors are from the same Renesas family, even if marking variations appear. The major advantage is that you do not need to solder the EEPROM chip separately. ACDP can communicate with both the processor and EEPROM through its specialized interface board simultaneously. It reads the D70F processor and the 95128 memory in one integrated operation that reduces physical risk to the board, eliminates capacitor removal, and significantly shortens bench time. From a workshop efficiency standpoint, this matters. Less soldering means fewer chances of lifting pads, damaging traces, or overheating components. For technicians who handle multiple clusters per week, time savings add up quickly. That said, CG100X still has its place. Some technicians prefer the granular control it offers. You manually handle flash and EEPROM. You see each file individually, and you have full visibility into every stage. In certain advanced recovery scenarios, that control can be valuable. But for routine cluster handling, ACDP's dedicated hardware design makes the job cleaner and more straightforward. So, let's answer the earlier question. Is the extra complexity of CG100X worth it? For highly experienced technicians who are comfortable with soldering and board-level work, it's a powerful and reliable method. But if your goal is efficiency, reduce physical risk, and faster turnaround, Yanhua ACDP clearly feels easier and more workshop-friendly for the specific Johnson Controls cluster. Personally, I lean toward tools that reduce board stress. Instrument clusters are not cheap, and a lifted pad can turn a simple task into a very expensive mistake. Simplicity, when engineered properly, is often the smarter long-term choice. But I know some of you will disagree, especially if you built your workflow around CG100X. That's exactly why I want to hear your perspective. Here's a quick tip that many technicians overlook. Before writing any modified data back to a cluster, always label and archive the original flash and EEPROM files in multiple storage locations. One external drive is not enough. Redundancy saves careers in this industry. So what's the final takeaway? Both tools can handle the Volkswagen Golf 7 JCI D70F3426+95128 cluster correctly when used properly. CG100X requires capacitor removal, EEPROM desoldering, separate flash and memory handling, and network verification. Yanhua ACDP streamlines the process with a dedicated interface and simultaneous reading, eliminating much of the hardware complexity. Now I want to hear from you. Which method are you using in your workshop right now, and why? Drop your experience in the comments. Let's aim for 1,000 likes and 100 thoughtful comments on this video. Only a small percentage of viewers watching Baabji Motors are actually subscribed, and subscribing genuinely helps the channel grow, reach #1 in this niche, and continue producing deep, hands-on analysis like this. These breakdowns take real bench time, real testing, and serious effort. Your likes, shares, and subscriptions directly support that work. If any tools mentioned are available through affiliate links in the description, using those links supports the channel at no extra cost to you, and I truly appreciate it. Thanks for spending your time here. Keep sharpening your skills, keep respecting the craft, and I'll see you in the next deep dive.